We said lesson 12, laws of exponents. I'm going to write just a review of addition at the top, adding, subtracting, because so many people get their adding, subtracting rules mixed up with multiplication. I'll just say adding with multiplication. And so when you add like terms, they have to have the same variable with the same exponent. So that would be 7x. And I meant to do the problem in it. I'll try to come back up there and remember to do it. I didn't with them second block. So number one, we're going to start with just the basic law of exponents when you're multiplying like bases. So if I have x to the 5th times x to the 3rd, 5 x's, and I usually try to do this on a couple of them, and 3 x's, and so when it all comes down to it, you're multiplying 8 x's, and so the shortcut is you can add your exponents. Cubed c to the 5th times, now they use parentheses some and put these in parentheses, and then I'm going to put a to the 4th and then c. So if you use that same rule, how many a's are you multiplying here? 7. And how many c's are you multiplying? 6. I have 5 here and 1 here, and I have c to the 6th. The coefficients, just like right here, are 1 times 1, which is 1, understood, 1 times 1, which is 1. Now let's throw one in that has like 8m to the 4th times 5m to the 6th. And I could actually come back and do this one, and I may come up there and do it there in just a second. I don't want to renumber it as a different example. But you multiply 8 and 5 like you always have. 8 times 5 is 40. That's easy. That's not a new rule. We know how to multiply numbers, integers, and then m to the 4th times m to the 6th would be m to the 10th. Now, if I come back up here and do 4x times 3x, when I did this in regular, I did it down in the problems, but I'll just do it up here. And this is when people are struggling with their rules, I'll usually write something like this at the top of their paper. And then 4 times 3 is 12, and x to the 1 times x to the 1 is x squared. And that's going to be important to us when we start factoring, because you got to be able to add and you've got to be able to multiply. Let's do 2 to the 5th times 2 to the 4th. And too many times in your multiple choice on the ACT, they like this one. I've seen this on the ACT before, is people will, one of the choices will be, I think you know it's 9 as the exponent, but they want to put 4 to the 9. But they forget your base, and I didn't redefine that. That base is the bottom number, got a base of x, and then your exponents are these numbers. And your like bases stay the same, and so it is going to be 2 to the 9th. And what I did for people who struggle with that one, I actually wrote them out. You have 5 2s, and you have 4 2s, and that's what I say. Do you have 9 2s, or do you have 9 4s? And that's why if you have to be careful on that one. If you want to know what 2 to the 9th is, don't forget how to do powers. And that's going to be, blah, 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 I've got it somewhere, 512. It's your 2 and then your house top and then your 9 as your exponent. Okay, second law of exponents. I did use one like number 1, and it's called power of a power. That's when I take like x to the 5th and raise it to the 3rd power. And that's not going to be the same as this. But if you think about what powers mean, if I've got 8 to the 3rd power, I know that's 8 times 8 times 8, so I've got x to the 5th times x to the 5th times x to the 5th, and if you go back to that law, I've got x to the 15. So what's the shortcut?
You just do 5 times 3.
Yeah, it's multiplication. If you have power of a power, it's a multiplication of those powers. So let's throw that into the mix and do, let's do open parentheses, 3a cubed c all raised to the 2nd power. Now the difference in, and I'll put a star by that one because that actually is the next law property. So I guess number 1, number 2, number 3, if they number them, oops, slide it over. Everything in here is going to be raised to that power, like this, and there was an understood 1 in there. 1 to the 3rd is 1. So in this case, I've got 3 squared, and it probably wouldn't hurt us to write that, especially in your notes, and because the exponent of the 3 is 1, And again, power of a power, 1 times 2 is 2. And then a to the 3 times 2 is 6. And then c to the 1 times 2 is 2. And then 3 squared is 9. A to the 6, c to the 2. People miss it because they want to just leave the 3. Some people miss it because they put 6. They're thinking 3 times 2. And I would say probably on the ACT, they will put those choices, so be careful. Now, throw in the same situation. Let's do -2, x to the 3rd, y to the 4th, z, all raised to the 4th. So we're going to raise everything in there to the, and I'm going to emphasize, and when we come back to this in just a minute, that is not a negative exponent. That is, the exponent is 1. So that's going to be -2 to the 4th. Now let's go over here and talk about -2 to the 4th. -2 to the 4th means -2 times -2 times -2 times -2. Now without the calculator, what is it when you multiply a negative number 4 times, an even number of times? Have you ever thought about it? A negative times a negative as a pair is always going to be positive, right? -2 times -2 is going to be positive. So that's +4, that's +4. An even number of negatives multiplied together will always be a positive, always. You know, -2 to the 100. I may not know what 2 to the 100 is, but I know the sign's going to be positive because they always pair up and you get positive times positive. So without even doing it with the calculator, I've got positive, and then that's 2 times 2 is 4 times 2 is 8 times 2 is 16. But if you type -2 to the 4th on your calculator, I'm going to do it 2 different ways. The calculator thinks that you're only raising the 2 to the 4th, not the -2. So if I type, get on screen, if I type -2 raised to the 4th, it's going to give me -16. Well, the calculator gave me the wrong answer. It did not. It gave you what you typed in there. It is doing this. -2 to the 4th means -1 times 2 to the 4th. In that case, only the 2 is raised to the 4th power, and that is -16. But -2 to the 4th, which is this, if you type it, has to have parentheses, and that's going to come up in the quadratic formula probably sometime before Christmas. I never remember when everything falls. So -2 to the 4th does give you the +16, which is actually that. So, long story short, -2, or short story long, I guess, -2 to the 4th is -2 multiplied 4 times, which is +16. That's the hardest part of this one. And then x to the 12th, y to the 16, and then z to the 4, because you're multiplying 1 times 4. Number 8, and actually I'm going to go ahead and do number 9 at the same time, and I'm going to put stars by both of them. Dividing with exponents. I'm going to do, and I'm not going to do such a big number on this one, I'm going to do x to the 5th.
You're not on the screen.
I'm not on the screen, thank you. Okay, and that notebook's not want to set up. I guess I need to go that way with it. Over x to the 3rd, and then underneath that, let's do a to the 2nd over a to the 5th. Now, the rule for this on most everything you ever see, in every textbook and probably on YouTube videos, says that if you're multiplying like bases, you add their exponents up there with number 1 through 4. And then if you're dividing, they say subtract them, which is great because x to the 5th divided by x to the 3rd would be 5x to the 5 minus 3. That's good. But the problem you get into is this. You have 2 minus 5, which is -3. In just a second, we're going to write a rule. You never leave negative exponents. So I either have to do something with a negative, or I treat it more as a factor tree rather than as an exponent, if that makes sense. Let's do this one. I'm not going to do it. This is the only one I'm going to do it on. If I have 5 x's on top, over 3, and I have no idea how Miss Christensen taught it. She may have taught it by the 5 minus 3. But when you start marking out what they have alike, this is a question I ask you. I say, how many x's do you have left, and where are they? To me, it's easier to say it that way. So you have 2 on top. So you have x squared on top. There's an understood 1 in front of all of this. So you've got a 1 here, a 1 here, which is still just x squared. The 1s are not going to be in a multiple choice on ACT. Now that makes this one a little bit easier, because if you have 2 a's on top and 5 a's on the bottom and you start canceling, how many a's are going to be left where? 3 on the bottom. A times a over 5 a's. So you're going to go the negative route, which you can, but I still think this is the easiest. Now the question is, what's left on top? A 1. Understood 1 in front. There's a 1 in here. There's a 1 here. And there's your setup. Now, let's put it, well, I need to do one more rule, and then we'll get into the negative exponents, which is going to be the rest of the examples. Anything, so I'm just going to put a raised to the 0 is defined as equal to 1. I'm going to write, you never ever leave negative exponents. If you do, I'm just going to say NS, not simplified. So in that case, if you had said a to the negative 3, then I would have said, yes, that's correct, but it's not reduced. It's like leaving 5 over 15. You got to reduce it. So don't leave negative exponents. So how do you get rid of them? And we're going to let the rule speak for itself. We're going to do x to the negative 4, and we're going to do 1 over m to the negative 3. I'm going to start with 1 on the bottom and 1 on the top, technically, because we know that's over 1. To get rid of a negative exponent, and I've never really looked up the official definition, I just always say it's like reciprocal, but it's only the part that's raised to the negative. So I say if it's on the top, it goes to the bottom. If it's on the bottom, it goes to the top. That's how you get rid of it. So in this case, if I've got, I'll put a 1 under that. That'll make it a little bit more sense. So if I've got x and negative 4 on top, and I need to get rid of that negative, it's going to become x to the 4 on the bottom. Now the 1, this 1 is not going up there. It's actually this one that stays there, and then this one stays right there. It'll make more sense with one of them in just a second. And then in this case, if it's on the bottom, it's going to go to the top. I didn't have to put a bar there. 1 over 1, and it's just m cubed. Number 13, let's do negative 12, x to the negative 4 over x to the negative 6. Now, this is a classic one, and I'd say probably the ACT likes it. They like the tricky ones. Your first instinct is to want to move that negative 12, but we never moved anything over here that was negative. I guess that's the only one where we had a negative. But the exponent's not negative. The exponent is positive. That has nothing to do with the exponent. So we only move negative exponents. When I taught this in Algebra 1, I would make them circle them. I'd say everything that circles is going to move. So that means the negative 12 stays on top. X to the negative 4 is going to go to the bottom, and x to the negative 6 is going to go to the top. And now you clean it up with your first rules that we did, that 1 through, well, your rules on page 32. That's probably the easiest way to say it. If I have 6 x's on top and 4 on the bottom, what do you have left? Where? 2 on the top. So you have negative 12 x to the 2. I didn't need that bar. It's over 1, which is just negative 12x squared.